Hi, I'm Mike Smith and welcome to this training on alternators. We'll go over the fundamentals of an alternator charging system, how alternators work, and where to find troubleshooting information. The main components of the charging system are the battery, the alternator, and the ECM. The battery is the primary source of electrical power on the vehicle. When testing the charging system, the battery should be at room temperature and the voltage should be between 12.4 and 12.6 volts. Test the battery before testing the charging system. Replace or recharge the battery as required. In order to produce the electromagnetic fields required to energize the rotor, current must be available to the alternator. Since the battery supplies this current, the battery must be in good condition. The alternator's job is to keep the battery fully charged and maintain the electrical system's voltage within specifications. Higher demands on the electrical system, such as lights, cooling fans, and warmers, place higher demands on the battery. The alternator increases the charging current output to keep the battery fully charged. Since the alternator's charging capacity decreases with engine RPM, the ECM monitors system voltage and can increase engine torque to maintain RPM. This function helps the alternator meet the needs of the electrical system at idle. If the ECM does not receive the reference voltage from the alternator due to an open circuit, the check engine light will turn on and engine torque compensation with changes in electrical loads will cease. Engine RPM would then drop with sudden increases in electrical loads, such as cooling fans coming on, heaters, or increased DPS loads. Unlike a magnetogenerator, which relies on permanent magnets to create the magnetic field required to generate current, an alternator uses field coils housed in a rotor to produce electromagnetic fields when excited by an outside voltage source. The internal voltage regulator monitors the electrical system's voltage and adjusts the output of the alternator by varying the amount of current being applied to the rotor field coils. This, in turn, increases or decreases the intensity of the electromagnetic fields produced by the field windings, and thereby controls the output of the alternator. The alternator is a completely self-contained unit. It houses the rectifier bridge, which contains diodes to turn the alternating current into direct current, an internal voltage regulator which regulates the output voltage to a predetermined level and also excites the rotor's field windings. The field windings are excited through the brushes that ride on the slip rings. Also, unlike most magnetogenerators, the stator is on the outside of the magnetic field instead of on the inside. The alternator sends the rectified and regulated direct current output to charge the battery. The alternator needs the battery needs the alternator, and the ECM monitors the relationship. The alternator's large positive terminal is connected directly to the battery. The alternator's housing provides the ground. The alternator terminal labeled L is typically for a charging system indicator light and provides the initial field current. On roadsters, a resistance is integrated into the circuit since the battery icon in the gauge is controlled by the ECM. Always refer to the vehicle wiring diagram. Should this resistor open, the alternator will not charge. The alternator senses battery voltage at the terminal labeled S. The lower the battery voltage, the more voltage the regulator sends to the rotor's field coil windings. The ECM receives a pulse width modulated reference signal directly from the alternator. The signal is used to determine the alternator's load at the current RPM. The ECM can then proactively increase the engine torque and therefore RPM to allow the alternator to produce more current. The alternator is driven by a shaft engaged to the clutch gear. The alternator shaft assembly uses a slip clutch to protect the alternator from varying power impulses transmitted from the engine. Two special tools are required to check the alternator shaft clutch slipping moment. The alternator shaft should start to turn at a specified torque. Refer to your shop manual for model specifications. If the slip clutch slips with too little torque, the shaft will not be able to transmit enough torque to the alternator. In turn, the alternator's output current will decrease. If the torque required to make the shaft clutch slip is not within specifications, replace the alternator shaft assembly. Alternators are extremely reliable and will often provide trouble-free service for the life of a vehicle. If charging problems do arise, the diagnostic procedures are similar to that of any other DC charging system. The shop manual contains detailed troubleshooting for these and more symptoms. Now that you know how the charging system works, make sure you refer to your shop manual for specifications.